revolutionized the field of clockmaking. At the heart of this innovation was the mainspring, a tightly wound coil of steel or other materials capable of storing mechanical energy. The mainspring served as the power source for the clock, replacing the cumbersome weights. This compact and efficient energy storage device allowed for the creation of smaller, more portable timepieces, including the early pocket watches. The mainspring was wound using a key or a knob, storing potential energy that would be gradually released to drive the clock's movement. However, harnessing the energy of a mainspring required precise engineering, particularly in the design of the escapement mechanism. The escapement acted as a control mechanism, governing the release of energy from the mainspring in a controlled, regulated manner. It ensured that the clock's gears and hands moved at a consistent rate, making accurate timekeeping possible. To achieve this precision, clockmakers had to master the art of creating high-tension, miniaturized springs that could store sufficient energy to power the clock while also ensuring that the escapement allowed for uniform, incremental release of that energy. This was no small feat, as it required a deep understanding of materials, geometry, and mechanics. In the hands of skilled clockmakers and watchmakers, spring-driven mechanisms ushered in a new era of timekeeping that combined precision with portability. Clocks and watches became not only functional timekeeping devices but also intricate pieces of craftsmanship, with beautifully designed cases and intricate movements. The transition to spring-driven mechanisms was not only a technological advancement but also a cultural shift. Clocks and watches became status symbols and pieces of art, showcasing the mastery of engineering and craftsmanship. They played a crucial role in shaping society, impacting everything from business and transportation to personal punctuality and the synchronization of daily life. The shift from weight-driven to spring-driven mechanisms in clock engineering was a transformative moment in horological history. It allowed for the creation of smaller, more portable timekeeping devices, expanded their accessibility, and drove the development of precision engineering skills. This transition laid the foundation for the intricate and finely tuned timepieces we admire today, and it reflects the indomitable human spirit of innovation and progress. The Industrial Revolution marked a significant turning point in clock engineering. Mass production techniques, powered by steam engines and later electricity, made clocks more accessible to the general public. Innovations in materials, such as brass and steel, enabled the creation of intricate clockworks. The Industrial Revolution, which began in the late 18th century and extended into the 19th century, brought about a seismic shift in manufacturing processes across various industries, including clockmaking. It marked a transformative era when traditional craftsmanship gave way to mechanization and mass production techniques, powered by steam engines and, later on, electricity. This transition had a profound impact on the world of clocks. One of the most significant advancements during this period was the adoption of standardized manufacturing processes. Prior to the Industrial Revolution, clockmakers crafted timepieces by hand, which was a labor-intensive and time-consuming endeavor. Each clock was a unique piece of artistry, but it also meant that clocks were prohibitively expensive and rare. With the advent of mass production techniques, clock components could be manufactured to consistent and precise standards. This standardization made it possible to create interchangeable parts, significantly reducing the cost of production and making clocks more affordable to the general public. This democratization of timekeeping meant that people from all walks of life could now own a reliable clock, enhancing their ability to manage their daily schedules and activities with greater precision. Innovations in materials also played a crucial role in advancing clock engineering during the Industrial Revolution. Clockmakers began using materials such as brass and steel, which were readily available and could be machined with greater precision than traditional materials like wood. Brass and steel were not only durable but also resistant to temperature changes and corrosion, ensuring the longevity and accuracy of the clockworks. These innovations enabled the creation of intricate and finely tuned clock mechanisms that could maintain accurate time